Hello, welcome to the webinar. My name is Stephen. Today we're going to explore the power of 5-axis machining in GibbsCAM. Let's get started. We're going to be looking at the 5-axis module today for simultaneous machining in GibbsCAM. Let's open up a 5-axis process to start. Before I create a toolpath, we'll just look at the process dialog for the 5-axis module. This is the options tab. It has, your speeds and feeds, and you can duplicate and rotate toolpaths, which CS you're going to be machining in. GibbsCAM 5-axis supports 3D cutter radius compensation, so you can adjust the toolpath at the machine for size. If I click on the surface paths, you'll see that GibbsCAM is very graphical in the 5-axis module. You'll see any field I click on is a diagram appears to let you know what the system is expecting. And that's right across the board, almost any field you click on. So it's very graphical, and it's a joy to use. Okay, you'll notice I'm in tool axis control, and we'll be machining in full 5-axis simultaneous. There's also, you can go 4-axis simultaneous, or you can lock both rotary axes and machine in 3-axis as well, in XYZ. So we'll be looking at that as well. Also, there's a lot of power to the 5-axis simultaneous machining strategy in GibbsCAM, and a lot of depth to it. If I just go over my calculation based on, if I'm selecting surfaces, there's a series of sub options here for different toolpath options. If I select triangle mesh, you'll see there's another series, a subset of toolpath options. So, and if I go to wireframe, you'll see likewise. So it goes, there's very many options here, okay? And we're going to cover off, a few of them here today. If I go back to options, you'll see there's a whole other set of toolpath options here as well. They're pointed 5-axis strategies, and we'll look at least the drilling one today. Let's go ahead and create a toolpath. Okay, so our options tab is good. We're set like this. I'll go to surface paths, and I'll select surfaces to start. We'll go morph between two curves. I'll just select the first curve like so. And I'll say, okay, the second curve will be in here. And then the drive surface, the surface we're actually going to be machining, is this one. So those morph curves are containing the toolpath, and we're going to be machining onto the yellow surface here. Start and end at exact edges, meaning the tool is going to travel right up to these morph curves that we've selected. But if we wanted to shift over, if we did that, it would perhaps overcut. So we can go to margins and add the internal tool radius, which is the radius of the tool we're using, which is, in this case, it's an 1/8" ball mill. So that'll shift the toolpath over by that amount. We're going to cut a zigzag toolpath, and we'll just use a standard. So it'll go from the left or right based on our decisions. There's the machining tolerance. We'll keep the step over rather coarse while we're developing toolpath. It'll calculate quicker. And once we're happy with the toolpath, we can tighten up our step over to create a nice surface finish. In tool axis control, we'll select full 5 here. There's dozens of options to control the tool axis in relation to the surface it's cutting. By default, the tool axis wants to stay perpendicular to the surface it's cutting. And for many reasons, you can alter that by adding a lead or a lag angle or a side tilt as well. And we'll discover them as we go. In the gouge check, this protects the part from the flutes where required, or the shank of the tool, or the arbor as well. We'll come back and look at that where required. We only apply gouge check strategies once the toolpath is created typically, and we see that there's a problem when we need the tool to move away from any given feature. The link tab is a very important part of the 5-axis module. These are important components of the toolpath. This is our first entry and last exit, okay? So the lead in and lead out. Gaps along cut are very important, okay? What is a gap along a cut? Well, this diagram kind of displays that. And so if the system encounters a gap, do you want it to go direct or follow a surface, or it can blend the spline, or it can start retracting to different feed or rapid moves as well, okay? And then you can differentiate between a small gap and a large gap and have the system behave differently based on those. Another one that's quite important is these links between slices. Well, what is a link? A link is the little piece of toolpath that joins the entire process together. So if you have a zigzag toolpath, there's a little piece of toolpath that links it together, and that is called the link as well. So you can go direct if you choose, or again, some of the similar options. If it's a far distance, you can have it retract to a feed distance or a rapid distance, and so on and so forth. Okay, again, you can differentiate between a small move and a large move. A small move, you may just need to follow the surface, but if it's a longer distance, you may want it to retract to a clearance area. So there's many different retract options, and if they're all defined in here, they're depths, okay? There's clearance area, which is the initial clearance plane. There's also a rapid entry and exit, and then, a feed entry and exit, and then a rapid distance here as well. Okay, and we'll explore these as we go forward. There's also a roughing tab. By the way, in the link tab down here, links between passes, you can do multiple passes, and then the same options appear here for how to get the tool from the end of the first pass to the beginning of the second. It's grayed out right now because we don't have any roughing strategy selected. If we come here to roughing and click any one of these, go back to link, you'll see that it wakes this up, and now we can behave. You can see the different pass levels here. Okay, so to create our toolpath, we have our edges selected. Yep, like so. We're taking 50,000 step overs. Our tool axis control was full 5. We had no gouge check strategies on. Our link tab, I was going to go links between slices. I was just going to say follow surface and follow surface in both instances. Let's go ahead and create that toolpath. Okay, down here in the lower right is the progress bar. There's a little thumbtack there. I like to keep this open during my session so I can see how long it's taking for toolpaths to calculate. Okay, so there we are. You can see there's the shift from the edge. That's the internal tool radius. We have a lead in and lead out option selected here, so I can modify those. If I go to the link tab, yes, we're using lead in and lead out. If I go to my default lead in and lead out, I can modify them here. Vertical tangent arc, I'll make them a little bit bigger like that, and I'll shift it over to the lead out just by clicking that button. I'll say okay, and we'll just hit the redo button. Okay, let's run the simulation here and have a look-see. And away we go. Okay, so this is OpSim right here. you can see right out of the gate that it has offended the blade there. Okay. And the step overs are rather coarse here. While we develop the toolpath, I'll keep the step overs rather coarse, and then we'll clean them up as we go. We'll see how it behaves coming up to the side of this blade here. Okay, so it seems to be clearing that one. This is our problem right now. So we'll add a gouge check strategy here. I'll go to gouge check. I'll select it. I'll check the flute and shank. Okay, there's three main gouge check strategies. Okay, retract tool. Okay, you can retract the tool along the tool axis, along any of the machine axes, or from any reference point you choose. It's quite versatile that way. Okay, you can, the next main one is you can tilt the tool. You can use a side tilt, which is a tilt angle perpendicular to the travel of the tool. Or you can use the lead lag angle, which is along the length of the cut as well. Or you can let GibbsCAM take over and say, do automatic. Well, in our case, we'll go side tilt. We're gonna have the tool tilt perpendicular to the direction of cut. Okay, the parameters are, you can limit it to a maximum of 90 and minus 90. We'll just leave that as it is. What surface are we gonna check? I'll just pick here and select the surface we wanna protect, is that one. We'll say okay. And we'll leave an amount on there. We're gonna have it missed by, we'll say 50,000. I'll say redo. And you can see there's a little jog in the toolpath, and let's look at the simulation. See how that behaves. I'll slow it down a little bit, hit play. So it comes down and you can see the tool is actually missing there. Okay, while it's running simulation, you know, you can single block it at any given time. You can put the tool holder on there as well. Okay, and as we go through and I show you the 5-axis, I will describe some of the features available in OpSim and in machine simulation as well. Okay, so we're milling with the end of the tool here. Okay, so a lot of the 5-axis module is end milling, but there's a very important component to 5-axis, and that's side milling. Okay, swarf milling they call it, side wall area relief feed. So let's do that. We will side mill one of the blades here. Okay, in this last example, this last toolpath, I use the edges of the solid to select. Well, that's, you know, you certainly can do that, but you can also use geometry that you have extracted from the solid. And I can do that in this case here. I'll create another 5-axis strategy. I'll use the same tool. Cutter comp is on by default. I'll turn it off until required. Surface paths. This time we're going to go swarf milling. Our swarf surfaces will be the walls of the blade. This one. Like so. I'll say okay to that. Okay. We'll use guide curves, which is the geometry. The upper curve will be the one on the top of the blade. And the lower will be this one. Okay. I'll say okay. The system will auto detect which side of the surface it should cut on. It's going to guide the tool at the lower curve. The start point is predetermined. We can change that. There is our machining tolerances again. That affects the quality of your toolpath. Advanced control, we can let it go automatic, or in this case, we're going to sync the toolpath with the upper and lower curves. We can add an extension on the beginning and end of the toolpath. We'll look at that. Under tool axis control, full 5, yes. Gouge check, we'll just leave it as it is. It's going to check the guide curves already. Okay, there's a lead in and lead out already defined here. We can remove them. If we remove them and say no lead in, lead out, you'll get an axial entry and exit. So just a straight line in. And you can do it in multiple passes. We're going to do it in one pass here. I'm going to say do it. Like so. There's a clue when you're developing 5-axis toolpaths on the entry and exit line. These lines right here. And with a bit of practice, you'll understand that this represents the axis of the tool. So it gives you a clue as how the toolpath is going to approach and leave the cut. Let's have a look at this one. I'll just turn off the holder. Sometimes it's nice to have it. Other times it might impede your view a little bit. Something like that. Okay. You may consider extending the toolpath a little bit here. I'll go back to surface paths, extensions, the start and end. I'll just extend it by, we'll say 50 thou at the beginning, and that same 50 thou at the end. I'll just say redo. You can see the difference there. Okay, at any time, and I'll do it on the next toolpath, is you can duplicate and rotate that around. There's no need to go around to each blade and do them separately. You do one and then you copy, rotate it around, like in other environments in GibbsCAM. Okay, let's go back to op1. We were saying that, you know, it's a full 5-axis strategy, absolutely no problem. But you can also lock a rotary axis or lock 2. Okay, so let's look at reusing the data that we did for op1 to cut the top of the blades. Okay, to simplify my view here, I can turn off the grid and the stock cube here. Let's go in and modify the data in this process dialog to do some 3-axis milling. It's basically going to be a 3D toolpath option, XYZ. I'll go to surface paths. And we'll select morph between 2 curves. Yes, the first curve will be this. And I'm picking wireframe from the solid again. The second curve, this one. Like so. The drive surface, or surfaces in this case, will be these 2. We'll start and end at exact surface edges, except this time I'll remove the this margin option so that the tool does go right to the edge and doesn't stay off it by the radius of the tool. I'll say okay there. We're zigzag machining. I'll set the step over to 25 thou. Okay, so you can do it by step over or by ridge height for surface finish considerations there. One drives the other. If we go to tool axis control, we're going to take it down to 3-axis. If that's the case, you can machine from the XY plane. Yes, Or if you click other direction and you have a coordinate system created, you can pick the CS that you want the tool to approach from and cut on using this one. So in effect, it's 3+2 machining or 5-axis positional milling. We're going to go by the top, which is the XY plane or CS number 1. Gouge check. Until we need it, I will turn it off. The link tab, again, we'll leave them as is. We'll create the toolpath and come back and modify as required. At this point, I'm going to create the toolpath. I can watch it run here in my progress bar. It ran rather quickly. And we can see our toolpath here. First of all, you see that the tool is now exactly on the edge. Okay. I see a problem here where once the toolpath leaves the containment of these morph curves, is the toolpath starts to flare out like that. Okay. So what we can do is we can virtually extend the morph curves until to the end of the selected surfaces. So if I go to the surfaces paths and surface edge handling, extend edge curve, and I'll say okay, and say redo. Okay, so that straightens that up pretty nice. If I go to a top view, we'll get a good look at that. Okay. Some other improvements are these are the links we were talking about. They're important components of the toolpath. And you can see that there's an abrupt change of direction there. So we would rather, if we could, and where possible, is have a nice blended curve in there. So if we go to the link tab, and knowing that there are links between slices, instead of following the surface exactly, we'll say blend spline in all cases in this toolpath. I'll say redo. You'll get a nice rounded curve there. One last thing you could do if you wanted just for safety's sake or what have you is have the toolpath push out beyond the surface. Is in surface paths, you can come to trim extend, and I'll extend the stroke of the toolpath. This is along the stroke. This is across the sides. Along the stroke, I will say I'll extend it by 25 thou on both ends. And say redo. Okay, so it just pushes it out there a little bit. I'll go to a nice ISO view. One more thing we can do here is I'll go back to the options tab, and we can duplicate this toolpath 7 times over 45 degrees and say redo. Like so. I'll just run the simulation again. And hit play. Away it goes. Of course, I would do that at the end to all of our operations so that the entire part was cut. Okay. I'll turn off edges here. So we've been creating toolpaths from scratch here. We've been building them up. In GibbsCAM, we have the ability to save these processes off. We can save all of the manufacturing data in here, your speeds and feeds, the different toolpath parameters. It also saves the tool off. So it's suitable for similar parts. So if we were cutting similar parts, we could have a series of processes available for that. Okay, so we're going to use those, and it'll just speed up our toolpath creation. Okay, we're going to look at this radial slot here. Okay, this is a 5-axis machine. Okay, has full 5-axis on it. However, if we were to rotate the part along the trunnion axis 90 degrees and access this slot, in a sense, we're now on a 4-axis mill. We could, although this is 5-axis, this is certainly can be done on your 5-axis or your 4-axis vertical mill or horizontal for that matter. Okay, so I'll load a saved process. I'll go load process, and I have one here called multi-axis rough. We'll let it load up. It's using T3, tool 3, which is a 1/4-inch end mill to cut this feature. We can measure the width of this slot rather quickly. I'll just measure across the width of the slot, and the slot's 3/8. So our 1/4-inch tool should fit the bill for a very quick and effective roughing strategy here for some of our 4-axis work. We'll set our speeds and feeds. I'll go to surface paths. Okay, we're multi-axis machining here. We're roughing, which is interesting. And many of the options within the 5-axis module is the offset milling, which is typical roughing. You know, it also supports adaptive roughing. Okay, with all the high-speed machining ability of other high-speed machining strategies, such as you know, all the curves and the corners and the micro lifts and like that. So you can do some effective roughing. In this case, we'll stick with offset milling. We're going to cut one way. We're going to climb mill. The step over will be 50,000 step overs, we'll say. Number of passes, 2. Okay, let's define the part. The part surface will be the cylinder that we're cutting. Okay, that defines the boundary of the feature we're cutting. I'll say okay. We're going to leave 10 thou on all surfaces there. Our floor surface, I'll pick it and say okay. Gouge check where required, link tab. Okay, we're going to have to gain entry to this slot. So we'll use a helical ramp in. Okay, so before I define what gets ramped in, I'll go to the roughing tab. We'll use helical. We'll say a 2-degree ramp angle, and we'll use 25. The ramp or the helical diameter will be 25% of the diameter of the tool we're using. Knowing that there's 2 Z depths or 2 passes that it's going to have to cut. The initial cut depth, we're going to use that ramp, yes, and links between slices or passes here, we're also going to use the ramp. I'm going to say do it. Okay. So it's using the ramp, and then these distances, we want to keep them pretty tight. The initial one's using the rapid distance, and this is using the feed distance. So I'm just going to make sure that they are, you know, close to the part, but still clear. Okay, I'll create a finishing cycle here, and then we'll run these 2 operations in simulation. So like we did 5-axis swarfing, we can do 4-axis swarfing here as well. I'll swarf the slot with a 4-axis process here. I'll go to surface paths. The swarf surfaces will be the walls of the slot. I'll go select tangent faces and say okay. Floor surfaces, yes. And then guide curves. For that, I'll turn my edges on. My upper curve. The lower curve. Okay. In this case, we'll go advanced control. Instead of syncing them, we'll go shortest distance here. Tool axis control, fourth axis. When you select the 4 axis, then you have to tell it what, where the rotary axis is, and it's along the Z axis of the part. So we're good there. Okay, this is going to go off center Y, and that's a big question when you're doing 4-axis milling. Of course, the 5-axis module supports off-center Y machining. If you wanted something more like polar and cylindrical, where the tool always pointed to center, where the button for that is right here. If you clicked on that, it wouldn't effectively machine this feature. Multi-cuts. This is a finishing pass. We're going to do it in one shot. And we just want to make sure there's an effective lead in and lead out here. So yes, we're going to use them. We'll go with a horizontal tangent arc, and I'll copy that over to the lead out and say, okay. I'll create this toolpath. Oh, okay. Let's run both of those in sim mode. Okay, so as you see right now, when I run opsim, is the tool rotates and the part stays fixed, something like that. I'll put the holder in and hit play. So there's the, it's helixing in to depth here, okay? So you see that happening. If you want a more realistic view of how it's going to appear at the machine, is you can change the POV lock here from fixed part to machine. Okay, and then we'll run it again, and now the tool will remain fixed and the part will rotate. There it goes. Okay, at any given time, there's a show position dialog in opsim that's kind of interesting. You can click on this, and there's sliders to control. I can just go, I can lift the tool manually in Z, lift it up out of there. And then I can determine my B axis is the rotary axis, and the A axis is the tilt or trunnion axis here. Okay, while we're doing all this, there's full collision checking. Okay, if the tool rapids any material, that's considered a crash. If the tool holder touches anything, that's also considered a crash, and the simulation will warn you that. Okay, so I'll take you in the next toolpath. We'll have a look-see, and we'll use not operation sim or op sim. We'll use machine sim. Okay, let's get ready to create a new toolpath here. I'll turn off my edges again. So we're going to do some 5-axis drilling. Okay, these holes here. We know nothing about them right now. We can just study the solid. So in combination with the 5-axis module, we can use the hole manager. So I'll select the entire model. And I'll run the hole manager here, turn it on. And we'll run auto feature recognition and give it a moment to go through the model. Okay, and it's identified them all. There's a whole feature for every hole now, okay? Some of you who use GibbsCAM may already use this feature. We're gonna use it in combination with the 5-axis drilling. If you wanna find out about something, you just click on it, and it tells you right here, oh, this one's a bolt hole. You can see about it. If you want some specific data about it, you can right click on it and go edit hole. You can see it's built from 2 segments. They call it a bolt hole, or a counterbore hole. Yeah, like that. There's a series of other ones in here. We can group them together now and then toolpath them all in once, drill them or what have you all in once, all at one time. So I'm going to group them by diameter. So I'll select, let's see, I'll grab this 3/8 hole and the rest of them. And I'll say make group. I'll just give it a name, something descriptive, something like that. What about these ones here? There's these bigger holes here. You can pick on them. Diameter 875, so they're 7/8 diameter. I see, 5 of them that are the same. So I'm going to group them as well. Give them a name. Oh, okay. So we're all set to go. When you need to select them, you just pick them by group. They all highlight. So we're good to go. I'm going to build up a process, grab it from our saved processes. I'll go with helix bore. So all of the drilling options that are available in the drilling process in GibbsCAM is available in 5-axis drilling as well. Okay, so we're picking drilling here. Under drilling options, we have all of our drill, the mill bore, tap, rigid tap, your pecking options, so on and so forth. Okay, we're going to go helix bore in this one. Okay, we're machining from the feature, so we'll be using the data in here. We want to concern ourselves with the bottom of that hole because we want the tool to break through the bottom. So if that's the case, there's some modifiers here. We're using the feature to create the tool path. We're going to adjust so that the tool starts 50 thou above the feature and the entire depth breaks through the bottom by this amount to full diameter depth. Okay. There's gouge check and a link tab as well. Let's create the tool path and see if they're required. I'll pick the 7/8 inch bores like so and say do it. It's as simple as that. Okay, it doesn't create a coordinate system. It supports, well, when we get to the drilling, it'll support drilling cycles as well. Okay, I'll do another one here. I'll go load process list and I'll peck drill those 3/8 inch holes. Okay. Let's have a look here. In this case, we're peck chip breaking. We're going to peck in by 0.15 inch, retract 25 thou. Again, we're going to make sure the tool drills through the bottom of the feature. There's an adjustment here as well, like so. I'll select the 3/8 holes and say do it. So there it is. I mean, it's done in seconds, really. Okay, you can see that without running the simulation, that the tool seems to be moving around quite a bit from hole to hole. There's not a lot of order in that. So we can reorder the group. Okay, right now it just is, this is the order they're being done, basically in chronological order. You can show the label of the features like that. But what we want to do is reorder them. So I'm going to use a rotary sort because we're rotating the part to drill these. We'll prefer a rotary direction. We'll go clockwise. We're going to sort it around the depth axis and say do it. Okay, you can see where it has reordered them here. I'll say okay, and we'll redo it. Okay, now you can see only one shift before it gets to the lower ones. Okay, so let's run that. I'll just close off the hole manager, and instead of op sim, we'll go to machine sim here. I'll put selected ops on and hit rewind so that we can have, let's see here. Okay, it's getting ahead of me. There we go. I'll hit rewind. It'll reset the machine up. Yeah, like that. And I'll hit single block just to, I'll slow it down a little bit. Single block it. And away we go. Okay, so that collision checking we were talking about in OpSim is also available here, except it's checking much, much more. It checks the spindle against any component or the coolant nozzles. It checks it all. Like that. If I turn off selected ops, meaning run all of the operations, now I can just kind of let that get going here and you'll see that it pops out. Yeah, like that. Okay, there's a couple other toolpaths I'd like to show you. If you want, you'll keep these whole features, but you can, along the floating taskbar, you can just turn them off so that they're not visible. There's 5-axis deburring, automatic 5-axis deburring in the 5-axis module. Let's just have a look at that. I can pick the entire solid and have it go at it and then exclude edges or what have you. But what I've done is I've created a feature that define the blades. And we'll have a look at that. So I'll open up the process dialog. Under surface paths, we're now deburring my part surfaces. I'll pick them. I'll open up my feature manager and just pick the blades. I'll say okay. Okay, you can exclude edges or check surfaces for fixtures, what have you. Here's the size of the edge break. I'll drop that to 10 thou. Okay, if tool axis control is vital here, we can just go full 5, which we are. Okay, but you can go 4+1, lock a rotary axis or the tilt axis and go. 3+2, as I was mentioning, for 5-axis positional milling. You can do on a 4-axis mill, or just straight 3-axis if you only had a machine, with no rotary axes. Okay, we're going full 5 here. It's as simple as that, really. Okay, one thing we're going to use is and it's available across the board, but this clearance blend spline, rather than an abrupt lift and over and then back down, it actually creates a nice curve reposition move, and you'll have a look at that here. I'll say do it. Give it a moment to calculate. While it's calculating, GibbsCAM is multi-threaded. It allows you to continue on. I could develop new toolpaths. I can solid model, create a tool, what have you. I'll go back to OpSim here. But you can see those, and I'll make sure that we are, yeah, fixed part like that. And hit play. So it's missing, as it cuts down the walls, it actually tilts the tool away. We'll have a look at that. So it's automatic deburring cycles, you know, and then you just exclude what you don't want. Very powerful. And here's the clearance blend spline moves, okay? And again, nice soft repositioning moves, easier on your machine, okay? We have one more toolpath we're gonna look at, and we're gonna wrap it up here. And it's basically just a straight 3-axis finishing strategy. Okay, I'll load it from the process list here. It's called Geodesic Machining. Okay, you guys may have heard about this, but it makes just high quality toolpath options. Okay, let's have a look at this. Under surface paths, it'll be geodesic machining. And what that means is that it puts a geodesic mesh over any surfaces you select and then machines that geodesic surface, okay? That's similar to triangle mesh, but the quality of the toolpath is just fantastic. Okay, so we never did focus on that surface there. I'll go guide curves. I'll pick this upper edge and the lower edge here. Okay, you can see that it didn't behave the way I wanted. So what I can do is just right click here and I'll go 2D chain rather, and double click on this edge again. And you can see it now chained it up the way I wanted. I'll include that one as well. Say okay. Okay, we're going to spiral up or down based on whether we have flip step over on or off. If we are spiraling, you typically want to do a full pass or full contour at one depth at the beginning and end, and we'll continue with that. Here's your step over amount by step over or by ridge height. Tool axis control. In this case, we said 3-axis, gouge check, only where required. Let's create the toolpath. I'll give it a moment or two to calculate, but very robust toolpath, very quick to calculate. Very high quality. Something like that. Let that run. Something like that. So that's where we're going to end it off today, guys. as you can see, the 5-axis module in GibbsCAM is very powerful and easy to use. We used 5-axis strategies. We went to 4-axis. We went to 3-axis. Hopefully we showed you a lot in a short period of time. There's much more to it. This was only the tip of the iceberg. There's a lot left to certainly display. Before we finish up, we're going to take some questions. Bart is here with me, Bart Ellers. He's been keeping an eye on the questions coming in during the presentation. If you have any questions now, just type them in. Yeah. And we'll do our best to answer them for you.
Hey, Steve, great job. We got several questions, but first, hey, great job showing, the power of the 5 axes. And like you just said a moment ago, there's so much power there, so many capabilities, so many machining strategies. It's just virtually impossible to show everything in a 45-minute webinar. But you did a really good job of just highlighting some of the real power. I really like some of the automated stuff, like the automated deburring, the hole manager, and the automated drilling of 5-axis holes. That just really helps decrease the programming time and efficiency. Like you said, we got several questions that came in during the webinar. I answered a few of them one-on-one, but there's some I thought would be good for the group. The first one we have is, can we change the angle of machining of the tool to 45 degrees? I'll let you take that one.
Absolutely, yeah, you can. In the tool axis control, you can put a lead on the tool, and I didn't really display that. It would have been suitable perhaps in the first toolpath option I created, and that way you're not machining at the tip of the tool, but by rotating the axis of the tool relative to the surface you're cutting, then you're cutting out on the radius of the ball or your end mill, and thus getting better surface footage.
Right. Agreed. Here's another one for you. Does the GibbsCAM 5-axis support TCP and dynamic work fixture or DWFOs?
Absolutely, yeah. The TCP is for 5-axis simultaneous, and as long as your machine supports it, the post and GibbsCAM will as well. And the DWFO, dynamic work fixture, that is for 3+2 machining typically, and yes, absolutely, all our posts support that in 5-axis.
Okay. Well, actually, here's another question I'll take and kind of ties into exactly what you just talked about. Someone asked, does 5-axis require a post upgrade? So it's a simple question, but it's a multifaceted answer. So I'll go through a couple of the scenarios. One is most people, when they get a 5-axis machine and they buy the 5-axis software, they just buy a 5-axis post. So there's no upgrade there. You bought a 5-axis post. Some customers actually have a 5-axis machine, only got a 3-axis post because they didn't have the 5-axis software, but eventually add the 5-axis software. And then in that case, your post does need to be upgraded to add 5-axis capability. And then the more common ones are what you just talked about, the TCP and the DWFOs. In order to support those, your software does it, if your machine can do it, and if your post doesn't already have that support in there, then you'll need to get your post upgrade. So there's a few scenarios where you may need to have your post upgrade depending on, what did you start with and what do you want now. The best way to get the answer for that is just contact your local reseller, and they can walk you through what you need to do with the post. If anything, your post may be ready to go. Excuse me, sorry. I'm going to take two questions and combine them together here. Will the 5-axis module work on my 3 or 4-axis or mill turn machines? I'll let you take that one, Stephen.
Absolutely, yeah. If you only, on a 3-axis mill, as we were displaying there, you can easily use the 5-axis module, lock out the rotary axes, and have yourself a 3-axis, toolpath creation engine there. It creates very strong 3D toolpath, operations. There's also, which I didn't show here, some very effective roughing strategies within the 5-axis. As I was saying, that adaptive roughing, it's available in different sections of the 5-axis module. Same as in 4-axis. It's sometimes you say, well, I don't need the 5-axis module because I only have a 4-axis mill. Well, the 5-axis module works very well in 4-axis. Again, you just lock out one of the rotary axes and you have a very effective 4-axis simultaneous machining toolpath engine there. And of course, it supports, off-center milling, which would have to do to be effective.
And then it will also support like a mill turn center, like it Integrex, correct?
Absolutely, yeah, really well in the Integrex.
Yeah, I think that's important to highlight because a lot of people just assume, and actually some of the other softwares only support the mill environment. When GibbsCAM integrated the 5-axis toolpath engine, we made it so that it went across our entire product offering. So whether you're in a mill environment or a mill turn environment, again, such as an Integrex, the 5-axis will support that. So if your machine can do 5-axis, GibbsCAM can support it. We're not limited to just the mill environment, where again, as some other softwares are. Here's the last question, because we're running right up against our hour. But here's one last question, and I'll tackle this one, but Stephen, you please feel free to jump in if you would like to as well. This one is, are there benefits to using 5-axis machining strategies on non-5-axis parts or features? So this ties right back into, will it work on a 3-axis mill? Will it work on a 4-axis mill? But this one's talking about parts specifically. And the answer to that is yes. In fact, what we're running into more and more and more is there are customers that only have 3-axis machines or 4-axis machines, but they want to use 5-axis machining strategies. And there's big benefits to this. You might be able to utilize, in a 3-axis environment, you might be able to utilize the side of this tool to do faster machining versus just doing ball end mill point to point over an entire surface. So the short answer is yes, you can use 5-axis machining strategies on non-5-axis parts and features, and there's some really big benefits to that, to tool life and machining time. I don't know if there's anything else you wanted to add to that, Stephen.
I could not. That was very complete.
Okay. All right. Well, then I'll hand it back to you to sign off, Stephen. That's all the questions.
Well, thank you, Bart.
Like I said, we're right at our 1-hour mark.
Yeah. Well, we certainly thank you guys for joining us today and attending this presentation. If you have any questions about GibbsCAM and you want to know more about it, you can contact your local GibbsCAM reseller. We're going to be sending out a link to the recording of this presentation tomorrow, and if you want to watch it again, or you can send that link to a colleague. We certainly appreciate you guys attending today. Thank you.